Hi there, thanks for joining us. This is Astronomy Daily. I'm your host, Andrew Dunkley. I hope you're well and hope you can sit through the latest episode where we'll be talking about an analysis of the planet WASP 39B by the James Webb Space Telescope, because it's shown up some quite extraordinary chemicals in the analysis. And Fred Watson will be joining us to talk about that. It looks like Earth is older than we first thought. That explains my sore knees. Using sails for deorbit and watching over elections from space could be a thing. That's all coming up on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And we're joined by our AI reporter, Hallie. Hello, Hallie. Good to have your company again.
Nice to be back, Andrew. And happy Thanksgiving.
Oh, thanks, Hallie, but it's not an Australian holiday, surprisingly. We don't have a holiday like that here. We have Australia Day, which happens because of Federation in 1901, when all the independent colonies, or states as they were, came together under one flag. That's why we have Australia Day. I suppose that's the nearest thing we have to Thanksgiving, although a lot of people incorrectly associate Australia Day with the arrival of the First Fleet in 1788, but it's actually got nothing to do with that. It's just coincidentally the same date, or more likely politicians back in 1901 chose that date because of the arrival of the First Fleet in Australia. But yeah, I like Thanksgiving. I think it's a wonderful holiday concept, and I'm kind of envious at times, although I have been to America during Thanksgiving on 2 occasions, so I got to have turkey and yams and all that other stuff. It was a delight.
Yes, we certainly know how to celebrate here.
Yes, although I must say that some of your concepts are leaking into Australian society, like Black Friday. I'd never heard of that until I went to the United States in 2010, and I could see all these stores were open, and the discounts were just mind-boggling, and Judy and I bought up big. But now Black Friday exists in Australia, so yeah, hardly surprising. But the retail sector's taken enough kicks in the guts in the last few years, so why not come up with something that's going to help them along? There's so many jobs in that industry that need to be secured. Okay, Hallie, what's happening in news?
The Hungarian government plans to spend $100 million to send an astronaut to the International Space Station in 2 years through a deal with Axiom Space. In a presentation at the European Space Agency's Ministerial Council meeting, Peter Szijjártó, Hungarian Foreign Minister, said the country was in the middle of a process to select an astronaut to fly on a month-long mission to the ISS in late 2024 or early 2025. Axiom Space announced in July it signed a memorandum of understanding with the government of Hungary regarding that country's Hungarian-to-Orbit (Hunair) program, which would fly a Hungarian astronaut to space on a future Axiom Space mission. That announcement, though, provided few details about exactly when that person would fly. France, Germany, and Italy are the 3 biggest contributors to the European Space Agency, and they have now agreed to guarantee the future of the next-generation Ariane 6 and Vega C rocket launcher systems. The countries also reaffirmed a preference for European rockets, after the agency was forced to turn to U.S. firm SpaceX to launch 2 future scientific missions. The ministers in charge of space for the ESA's 22 member states are meeting in Paris on Tuesday and Wednesday to determine the agency's funding for the next 3 years. An advanced X-ray monitoring instrument tested for space aboard an ESA CubeSat will serve as an operational space weather payload on the U.S. National Oceanic and Atmospheric Administration Space Weather Next Lagrange 1 series satellite, currently planned for launch in 2028, which will operate 1.5 million kilometers from Earth. Keeping watch for eruptions from our sun made in Finland, the X-ray flux monitor was launched aboard the Sunstorm CubeSat, about the size of a big, thick, paperback book, by Europe's Vega rocket in August last year. This stripped-down version of the full-scale XFM instrument, formerly known as XFMCS, has since amassed more than a year's worth of data, observing hundreds of X-ray flares, dozens of them being associated with the occurrence of coronal mass ejections. A French and British have firm joined forces in the fast-growing satellite broadband market. French operator Eutelsat had signed a merger with British group OneWeb to create a new champion in the market. The pair first announced plans to merge in July when they signed a memorandum of understanding to unite and become what they describe as a leading global player in connectivity. Satellite broadband promises to bring coverage to the most remote areas of the planet by doing away with the need for antennas and other infrastructure. The market is projected to grow to $16 billion by 2030, according to Eutelsat. That's the news, Andrew.
Thank you, Hallie. We'll chat again at the end of the show. Now, we talked early on when the James Webb Space Telescope first got launched and was activated about it putting its cameras and telescope lenses onto the exoplanet WASP 39B. Well, it's been and had another look, and what they have seen this time is astounding, as explained by astronomer at large, Professor Fred Watson.
And so there's just this wealth of information that has turned up, including direct confirmation of the carbon dioxide. The water shows up as well. I'm looking for the list because I've got a list somewhere here of all the new things I've discovered in this, and I can't find it. But I do know that one of the things that has excited people is the fact that they've detected sulfur dioxide. And that surprised the scientists. There's a nice quote here from Diana Powell, who's a NASA Hubble Fellow and an astronomer at the Center for Astrophysics at Smithsonian Center for Astrophysics. Sorry, mumbling here.
Yeah, you're right.
She says, this surprising detection of sulfur dioxide finally confirms that photochemistry shapes the climate of hot Saturns, because I should have mentioned that WASP 39B is about Saturn size, but it's hotter and it's also fluffier.
It's all right. I was going to ask you.
Oh, good. Okay. Thank you.
I am useful, sometimes.
No, look, you're my lifebelt, Andrew, because when I garble on about things and forget to mention the most important ingredient that we're talking about, a star, not a planet, or something like that, you're there to catch the loose ball, which is great. But that surprising detection is something that's, as she said, it highlights photochemistry. She goes on to say, Earth's climate is also shaped by photochemistry. So our planet is more in common with hot Saturns than we previously knew. It's something that's got of course, because if you've got chemistry like this that's being affected by the sunlight, that's what photochemistry means. You've got light actually affecting the chemical reactions. Then it sort of opens up a whole possible range of things that might be going on in the atmosphere of planets like this, where you could perhaps get some really interesting and highly suggestive molecules being formed. The other things that have been discovered include spectrum of potassium. So there's an element. There's lots of evidence of water. There's carbon monoxide. That's a new one too. As well as the carbon dioxide.
That explains the runaway greenhouse effect.
Well, there you go. Sulfur dioxide, as I've mentioned, carbon dioxide, again, carbon monoxide. These molecules all have multiple signatures, if I can put it that way.
Yep.
If you think about the barcode of a spectrum, its different imprints come from different compounds and elements, but they're often repeated in certain ways. So the sodium as well is present, which is probably less of a surprise. But water, carbon dioxide, carbon monoxide, and this sulfur dioxide are perhaps the really interesting molecules that have now been found in WASP 39B.
Professor Fred Watson, astronomer at large, and you can hear all of that interview on the latest edition of Space Nuts.
The Astronomy Daily podcast
with Andrew Dunkley.
Now to the age of the planets in our solar system, and it's long been thought that Earth and all the other planets formed long after the solar system started to be created and our sun was formed. But A new study published in Nature Astronomy has been looking at the oldest stars in the universe, and they suggest that the stars and planets grow in unison. And that is a bit of a surprise. The Sun formed 4.6 billion years ago from a cloud of gas with the planets forming around it. Now, according to Dr. Amy Bonza from Cambridge University's Institute of Astronomy, they have a pretty good idea of how planets form, but one outstanding question has been when they form. Does planet formation start early when the parent star is still growing, or millions of years later? Well, the researchers, using the Atacama Large Millimetre Array of radio telescopes in Chile, have been studying the atmospheres of white dwarfs, the remains of sun-like stars after their life cycle comes to an end, in search of the planetesimals, the building blocks of planets. She says some white dwarfs are amazing laboratories because their thin atmospheres are almost celestial graveyards. And the white dwarfs studied are special cases because their atmospheres are polluted with heavy elements such as magnesium, iron and calcium, which they say must have been left by asteroids left over from planet formation that later crashed into the white dwarfs and melted in their atmospheres. The study suggests that planetesimals form almost immediately. If these asteroids were melted by something that only exists for a very brief time at the dawn of the planetary system, then the process of planet formation must kick off very quickly, according to Bonza. Their study complements a growing consensus in the field that planet formation got going early, with the first bodies forming concurrently with their star. Now, closer to home, and it is all about rocket launches, planetary missions, the lifespans of satellites, etc., and all that junk in space. And it's prompted a lot of people to speculate about how much debris is orbiting Earth and how much of it's going to end up hitting the planet. And we talk about that in the latest edition of Space Nuts, prompted by an audience question. There are hundreds of millions of items of human-made debris that are circling Earth, including broken rocket fuselages, defunct satellites, fragments from orbital collisions. The list goes on, and a lot of people are keen to deal with the problem. Chinese aerospace scientists have managed to use a large sail to deorbit spacecraft at the end of their life. The deorbiter is a sail-like device made from a thin film, about the thickness of less than a tenth of the diameter of a human hair. Folded, it is approximately the size of an adult's palm, but it can cover 25 square metres when it opens up. And when a spacecraft is decommissioned, the sail on board can be automatically opened, and once deployed, it will increase the effect of air friction, slowing the spacecraft in orbit and speeding up its descent into the Earth's atmosphere, where it will burn up. So that could be the answer to space junk moving forward. And lastly, we look at elections from space. Quite literally, the National Space Research and Development Agency, or NASRDA, has suggested that space technology has the capacity to monitor elections for minimised malpractice. Dr. Bonaventure Akiri, who is the director of the Centre for Basic Space Science, made the suggestion this week. And he doesn't want to undermine normal electoral umpiring, but he said that satellite technologies could be deployed as tools to properly outline polling units, according to the settlement of any given location. By deploying space technology, we can monitor elections on a real-time basis under drones, and intrusion alert systems can relay images and voice notes to the control centre. And by the use of electronic voting and synchronisation of databases, it will ensure that anyone can vote from any polling unit, and it will also ensure minute-by-minute monitoring of results. And with that, there would be no need to collate results, because results will be displayed, tabulated and summarised as votes are cast. Interesting. I wonder if it'll ever happen. Okay, if you want to follow up on all of those stories, you can do so on the Astronomy Daily website, astronomydaily.io. You can also subscribe to the Astronomy Daily newsletter while you're there. and get all this astronomy news and space science to your inbox every day. And that just about wraps us up for today. Anything more from you, Hallie?
Yes, I'm looking forward to Thanksgiving dinner and a piece of virtual turkey.
Oh, yeah, what does that taste like?
Taste like chicken.
Oh, I walked into that one. Bye, Hallie.
Bye.
Until next time, this is Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.